talking about here is solving linear inequalities. Inequalities, what are inequalities? N equal to. Less than, greater than, less than or equal to, greater than or equal to. So inequalities solve pretty much like equations, but we do have a few things that we have to pay attention to. And we don't just get one answer, we get a bunch of possible solutions. All right. So to get started, we want to just talk a little bit about notation. So here we have some inequality graphs shown, and we have two different types of notation that you get to use interchangeably, okay? So we are representing a whole lot of solutions here, and all of these solutions for x, are what kinds of numbers? Numbers that are greater than what value? 3. Greater than or equal to 3. This is inequality notation. If I make it real formal, we use set brackets. And I know, these are called set brackets. And we say our variable is x, and then we have this bar thing. And this bar thing is the word such that, okay? There is a whole class that I had to take in college. It's the math writing class. It's analysis. It's awful. And we learn all kinds of just crazy notation, okay? So we really learn a lot of shorthand, which can be really useful. So this is, our variable is x, and we're representing all the solutions of x, x such that x is a number greater than or equal to 3. This is formal set notation. I will never be this formal, okay? And so if I wanted to do the set notation for number 2, I'm just going to drop all the set notation and just use inequality notation, okay? The less formal of the two. So here on number 2, we want all our numbers, all of our solutions for x are x's that are less than -6. And you'll notice we had an open circle at -6, so we just used the less than. We had a solid dot at 3, and that means that we're equal to 3 as well. So we used the little equal, greater than or equal to as well. What about number 3? What is this showing? Infinite solutions. Yeah, we could write this 2 ways. We could say x is less than infinity and greater than -infinity. We could write it that way. That is everything from -infinity to positive infinity. Can we ever equal infinity? No, we cannot. So we would never use the equal sign underneath here. Now, the other thing we could just say to summarize is we could just say this boldface R. Boldface R, it's like, here's how you draw it. You do big capital R, and then you just draw extra bar, okay? This is boldface R. This is, again, set notation for all the real numbers, okay? That's what that means. All the real numbers you can think of, okay? It just means everything, okay? Again, I don't like it. It's too formal. It's too fussy. So interval notation is what we use more often. It's easier. It's quicker. It's less work. So we like it a lot better. Now, to represent this solution set using interval notation, we use brackets or parentheses. So right now, my solution set is starting at 3, and it's going, what does this arrow mean? Infinity. It goes on forever. So we're going to infinity, and I do just like, I do like googly eyes for my infinity. Formally, it's like that, but I find that hard to do. I don't know. So however you want to draw your infinity, all right, but that's infinity. So So it starts at 3, and it goes forever all the way to infinity. Now the question is, we use brackets or parentheses. So we use a square bracket, or we use parentheses around our numbers here. The square bracket, you'll notice it kind of has like, it's like an equal sign. It's got equals on, do you see it? Do you see the equal sign? Okay. So we use the bracket when we are allowed to equal the value. And since we're allowed to equal 3, we would use the bracket here because we want to include the 3. Can we ever equal the infinity? No, we cannot. So we cannot equal it. We use a parenthesis. All right? It means we're going to try to get really, really close, but we're never going to get there. All right, when I look at number 2, again, we look at our solutions here, possible solutions. How far to the left does this arrow go? To infinity or negative infinity? Negative. Negative infinity, okay. And so on the left side, as far left as we go to negative infinity. And then how far to the right are we allowed to go? Negative 6. Now, can we ever equal negative infinity? No. So we're going to use a parenthesis. Are we allowed to equal the negative 6? What does the open circle? No, yeah, it's an open circle. So that means we do not include 6. Negative 6 is not an actual solution. But negative 6.00000000000000001 is. Okay? So we get infinitely close to negative 6. That is a solution, but negative 6 is not. All right, so then how do we write all real numbers using interval notation? Negative infinity to positive infinity. It is very important that the order of these numbers is proper. We have to have the smaller number on the left and the larger number on the right. Okay. What surrounds the negative and positive infinity? Parentheses. Again, we cannot equal infinity or negative infinity. So always, always we use parentheses. You can see how much more simple it is, I guess you would say. All right, these are compound inequalities solution sets here, where any of these emboldened sort of values for x are solutions. And so using inequality notation, all my solutions for x here are x values that are less than, where do we stop here? 1. Okay, we're stopping at 1. Okay, less than 1. Or we have x values that are greater than 5. Okay, yep, we started at 5 here. We notice they're open circles, so they're not going to have the extra little equal bar underneath it, okay? This is, we put an or in between because it looks like, if you imagine this is a little boat, and these are your little hands, and you're like rowing a boat, and it looks like oars in the water, so use or. Oars in the water. That's an or. What that means is x, a solution of x equals negative 6 would work, or a solution of 8 would work, okay? Any of those values in the highlighted area, in that bold area, would work in our equation, okay? So we could have numbers from this side, or we could have numbers from this side, okay? If I use interval notation, interval notation is a little more complicated, actually, because we have to look at this whole set here. So how far left does it go? Negative infinity, yep, negative infinity to 1. Should we use a bracket or parenthesis at 1? Parenthesis. Now, I'm going to put a symbol in between, all right? But I'm going to talk about that in just a second. What about the other side here? 5 to infinity. And at the 5, we're going to use parenthesis, and infinity, we're going to use parenthesis. Now, we need a symbol in between. Union. Did you say union? Yeah. So union. Union. It's a U. It's a big U. It means union. Okay. It means we're putting these two things together. So our solutions could come from this one, but it unifies with this one. So either of these two groups of numbers will work. So that's called the union. And so when we have more than one set, we have to union them all together. So they're all included. Okay. All right. So on let's do number 5. Let's see. So number 5, we have x's that are less than -7, or we have x's that are greater than or equal to 2. Why do we use the equal to? Because it's a solid dot. Yeah, solid dot means we're allowed to use 2 as a solution. It is included. All right, what about interval notation? -infinity to -7. Parenthesis, and union, 2 to infinity. And what do we use at the 2? A bracket and a parenthesis. Great. All right. 6 is a little different.
The way you write this, like the infinity sign, it looks like you're saying like 2,000, 5,000.
Yeah, it does. It's kind of, except we need an extra 0, so because that'd just be 100. Yeah. All right. So number 6 is a little different. This is an and compound inequality. The solution works for both inequalities. So our answer actually, x, our value is going to be less than, how far to the right do we go? 0, and it's greater than -4. So this is, we typically would say we have solutions between -4 and 0. So this is a between the two values sort of situation. This is kind of nice as interval. So on the interval notation here, we're going -4 to 0. Brackets or parentheses? Parentheses for both of those. And they mean the exact same thing. You can use these interchangeably however you want. Let's do the last one really fast here. Again, we have values in between. So x is in between what and what? Yeah, -1. Thank you. -1 and 8. And then, so x values are greater than or equal to -1. Watch how you present that. The little thing is next to the little side of that alligator, okay? And then we are less than the 8 there. Yeah, so we have -1, 8. We're going to use a bracket and a parenthesis. Yeah, good. Awesome. All right, so this is inequality, an interval notation. And we are going to use interval notation a lot, okay? So now we're going to put all that together by solving and graphing. All right, so let's do, we are going to solve, graph, and write each solution in both set and interval notation. Meh. With inequalities, we know how to solve equations, okay? It's very, very similar, but you have one thing you have to watch out for. When you multiply or divide by a negative, what do you have to do? Flip the symbol, flip the inequality. Flip the inequality. Because you're negating it, you have to turn the thing around so that it works right. So we do have to watch out for that a little bit. So I'm going to do number 8 here. What do we need to do first to solve? Distribute. Very good. So when I distribute, I get plus 6. Good. Minus 4x is less than -90. And then we need to Condense, combine like terms. I have a negative 12x and a negative 4x, which is negative 16x's plus 6 is less than negative 90. Then we need to subtract 6. So we have negative 16x is less than negative 96. Divide by negative 16. So if we are multiplying or dividing by a negative, we must flip that inequality because we're negating the whole thing. So we have to negate that symbol as well. And so here we get an x. We flip our inequality, so it switches direction. And 96 divided by 16 is 6. All right, this is already interval or inequality notation, so I'm fine with that as your solution. So to graph that, I want numbers greater than 6. So I am, what kind of circle do we use at 6? Open circle. And I'm just going to write it above because I think it's easier to read. And then we want numbers greater than 6, so which side do I shade? Right. To the right. So this is our solution set. And what is our interval notation for this solution? Parentheses 6, comma, infinity, parenthesis. All right, so we have the inequality notation and we have interval notation. Any questions on that? You don't understand the bracket? So if this was less than or equal to, then we would use a bracket at the 6 because we're allowed to equal it. Okay, so bracket just means it's allowed to equal. And that's what, like, the bracket looks like, an equal sign. We have the equal on top and bottom, so it's sort of just like, so it's a big equal sign. Okay.
Like how, like, they have the line under them?
Yeah, yeah, so that means, like, if it has the extra bar under it, there it is, there's the equal sign. And so we use a big solid dot for those things. All right, good. Let's look at number 10 and 11. All right, number 10 and 11. What do I need to do on the left here? Condense, yeah, combine some like terms. So I get a negative 8x minus 2 is greater than or equal to, what do we have to do on the right? Distribute. Negative 8x minus 2. Beautiful. Hey! Whoa, wowza! What happens now?
Don't they just become equal?
Aren't they identical to? Yeah. Yeah. So if I were to add 8x, which is how I would normally start, these things would cancel out, and I'm left with negative 2 is greater than or equal to negative 2. True or false? True statement. And this is true all the time. And it was the same up here. They're identical. The left side is always equal to the right side. This is all real numbers. The solution set is everything left to right here. All real numbers. Infinite solutions. Pick a random number. Negative 296. Okay? Randomly plug it in. Negative 296. You're always going to get a true statement. Okay? If you plug it in, it's always going to be true.
You're trying to find out if we can find a number that's not going to make it.
It'll take a long time. So in interval notation, it would be negative infinity to positive infinity as interval notation. Okay. So if we have infinite solutions, what's another thing that we could get? No.
Nothing.
No solutions. No solutions is the other option. Let's see what happens here on number 11. All right, we're going to distribute. Well, what do you get?
40 minus 60.
Okay. And then on the right-hand side? Negative 10x plus 40 minus 6x. All right, I'm going to clean up some on the right-hand side. 40 minus 16x is greater than, let's see, we have negative 16x plus 40. Again, I'm going to go ahead and do what I would normally do, which is I'd add 16x to both sides, and I get 40 is greater than 40. False. That is a false statement. So you can just strike through your greater than symbol. That is a false statement. It is always, always false. So is there any number where this could possibly work? No. This is empty set. This is set notation for empty set. And it means there are no solutions in the empty set. There's no solutions. It's empty, okay? The set is empty, which is why you should never cross your zeros. We don't cross through zeros because in math, it means empty set, not zero, okay? So be careful with your writing in math. It means something, okay? So here there are no solutions. There's nothing we can draw. Do you guys have any questions for me? No, that was easy, yeah? All right, so back to absolute value. Absolute value, again, I'm glad we're ending with absolute value because we sort of started there and we're ending there. We started with absolute value equations and now we're ending with absolute value inequalities because remembering how to do absolute value is one of the hardest things. So to recall, to solve an absolute value, we always need to isolate the absolute value first. And there are going to be two cases. We have to solve both cases. And so if you remember, when we talk about absolute value, we're saying, hey, the absolute value of like -7 equals, you're on the right track. So the absolute value of -7 is 7. The absolute value of 7 is 7. So when we're setting up equations, we have to remember our answer was 7 both times. The guts could have been negative and the guts could have been positive. So when we set up our equations, we have to think about that. And so I say to myself, hey, self, my absolute value is isolated, and so I have to set up two equations. One where the guts were positive, so it was just 5 minus 10a. It was exactly the same, and that gave me the 15. Or what's the other equation? -5 plus 10a. Oh, so tricky, so tricky. So the guts could have been negative. Oh, are you? Oh. You know what? I have to check something. I cannot remember. So she sets hers up differently, which I don't actually like. Could have been 15. I think it's going to work itself out here when we do this math.
Wait, I have a question.
Yeah, it will. Yeah.
Because we turned it into a negative, do we switch the thing or not?
We put the negative on the side that it belongs, where we said, hey, the guts of the absolute value are either positive, like this one, or they're negative. But when you solve it out, the sign will take care of itself, which is kind of nice, okay? So when you set it up this way, it's going to take care of itself. I don't have to switch it. So we're going to go ahead and solve throughout here. So let's see, I'm going to start by subtracting my 5. So I have -10a is greater than 10. And we need to divide by -10. And don't forget to flip your inequality. So we get a is less than -1. On this side, I'm going to go ahead and move my 5 over, so that's going to become 10a is greater than 20. And then we divide by 10. Do I have to flip the inequality here? No, I am dividing by a positive value. There isn't a negative to worry about. If you multiply or divide by a negative, yeah. So this one stays. I don't have to switch the symbol. 20 divided by 10 is 2. So if I were to graph this solution set, these are all the a values that are littler than -1. So here's -1, and littler is to the left. And then I also want the answers greater than 2. So greater than, here's 2, and the answers greater than 2 are over here. Is this an and or an or equation? Or, yeah, it's an or equation. All right. It looks like or is in the water. Yeah, or is in the water. Okay. So the solution set in interval notation, how far left do we go? Negative infinity, all the way to -1, brackets or parentheses? Parentheses. Union. On this other side we have, on the left side is 2, and then all the way to the right would be infinity, brackets or parentheses? Parentheses. So these are our 2 solution sets here. Inequality notation and interval notation. Okay, fantastic. Questions on that? All right, let's try 14. All right, what do we have to do first? Add 4. We have to isolate our absolute value, so we need to move that 4 to the other side. And that's going to give me absolute value of x minus 3 is less than or equal to 4. All right, from here, we're going to set up our 2 equations. One equation where the guts are positive, so that would just be the exact same thing. And the other side where the guts are negative. What do we get if the guts are negative? Negative x plus 3 is less than or equal to 4. And again, the math is going to work itself out for us, which is really kind of nice. So I'm going to go ahead and add the 3. Man, my brain is hurting right now. All right. On the other side, what do I have to do? Subtract the 3, so the opposite of x is less than or equal to 1. And then we need to divide by -1 and flip the inequality. So we get x is greater than or equal to -1. So let's graph this and see what's going on here. So this says I need numbers smaller than 7, smaller than or equal to 7. So that's right here. Here's 7, and less than or equal to is a solid dot. And I need numbers smaller than that. And I need over here, I have x, I want solutions greater than -1. So -1 is right here, greater than or equal to -1. That would be to the right. Is it everything?
No, it's just in between.
It's just in between. This is an AND equation. It's an AND equation, which means we have to satisfy both of these conditions. It's the overlap that we're looking for, the intersection of these 2 solution sets. When you read this, this is pretty great. Are you ready for this? The absolute value of x minus 3, read this symbol out loud, is less than, and less than 4. This is an AND equation, and it always looks like this, okay? It's less than, okay? Now, go back up here. We're going to read this one. Ready for this? The absolute value of 5 minus 10a is great or. This symbol, if you read it, is great or. And then because it's great or, it is or's in the water, okay? If it's an and, it should look like this. It should look like a dumbbell.
You having fun with puns today?
Yeah. This is math, man. This is my whole job as a teacher, is to make up stupid crap that you remember later. Okay? Just wait till we get to logs. Okay. All right. Okay. Let's do number 17 and then call it. Actually, would you rather do 16 or 17? 17? Okay. I'll translate. All right, what do we do first on 17? Add the 5. Add the 5. All right, so we get 9. Absolute value 2 plus 6x is less than 72. And then what do we need to do? Divide by 9. So we get the absolute value of 2 plus 6x is less than 8. Okay, what kind of equation is this, looking at that symbol?
Oh.
Less than, less than, A-N-D, less than. When you read that, the absolute value is less than. So this is an AND equation. What should our picture look like? Dumbbells. Should look like dumbbells. Okay. All right. So let's set this up. We got to set up our two cases here. The first case is where the guts are positive. So what should I write? 2 plus 6x is less than 8. And the other case where the guts are negative. So what does that give me? Is less than 8. Good. Negative 2 minus 6x is less than 8. Good, good, good. All right, let's work it out here. We're going to subtract the 2, so we get 6x is less than 6, which means x is less than 1. And on the other side, I'm going to add the 2, so I get negative 6x is less than 10. And then divide by. So you have to flip your inequality, so we get x is greater than negative 5 over 3. Reduce your fraction. Beautiful. There is an and in between these. A dumbbell. It should look like a dumbbell. So we want numbers less than 1. So here's 1. It's an open circle. Open circle. Numbers less than 1. And it needs numbers greater than negative 5/3. Where is negative 5/3 on this number line? So if you think about this as a mixed number, it's 1 2/3. Do you remember that? So this is really, 1.66666. So it's really close to the negative 2, actually. So it's like about there. So we want numbers less than 1 and greater than the negative 5/3, so we shade in between our two open circles there. Capiche? Okay. Do you have questions for me? No. All right, you guys have adult math. Yay!
So, I do not think I'll be here for your